Good afternoon, students. So in the last lecture, we started with the chapter 4, and chapter 4 is about machine learning. So we started with the syllabus. So here we have seen which are the concepts of machine learning, that is overfitting. What is in the overfitting, train and test splits. So overfitting, it means that we are having two types of the data, training data and test data. So training data, it means that on which we build our model. Model, it means that we are building some equations which will give me some input and will give me output. So training data, it means that which is having input as well as output. So based on that, we decide, means we decide which formula, that is how to build a model, or how to design a mathematical relation between the features of my between the features. That is, if I'm having for a particular object, if I'm having multiple features, then what can be the relationship between those, so that I can categorize into some category or identify the object, etc. It means, for example, if I'm having the multiple objects and out of that I wanted to recognize an object, then it means that whatever the values or feature values we are taking, for example, color, weight, design, or shapes, or etc. For example, I wanted to find out the cell phone, or consider there are multiple flowers are there, and out of that I wanted to check whether current flower or whatever the flower is there, how many categories or how many types of flowers data I'm having. That is, if I wanted to classify the flowers, or if I wanted to perform or check which kind of flower is that. So in that case, training data, it means that initially I will have the feature values. For example, when it comes to the flower, then we can say how many petals are there, what is specula, etc. It means stigma, what is the length of flower, etc. It means that these can be acting as a features, and within that, when I'm giving some output, that is, yes, this flower is hibiscus or this is something else, etc. So it means that I'm defining a mathematical model that these will measure the dimensions or study the features of my flower, and then declare that yes, that feature or that flower is a hibiscus. So it means that here training data is given. So in case of machine learning, whenever we are passing a training data, along with the training data, we are having the output as well. So output, if consider we are designing some mathematical formula, which is called as a model in terms of machine learning concepts. So that model will design some formula, and based on that, it will check whether for given input of the values, I'm getting the correct output. If I'm getting the correct output, it means that my model is correct. So overfitting, it means that here generalization, it means that consider that for the 10 or 15 or 100 samples, I have designed some model, and that model also works with the test data. Test data, it means that which doesn't have an output, only input features or input values are there. I don't know what can be the category of, or what kind of flower can be there. So test data, it means that which doesn't have a label or which doesn't have a output. So if our model exactly gives a correct answer, then it means that model is called as a generalized model. So here there are three concepts: generalize, overfitting, and underfitting. So generalize, it means that the model works with the trained data as well as the test data. Then underfitting, it means that I've designed the model, but on the trained data also it doesn't work properly. Then that model is called as a underfitting. And overfitting, it means that along with the trained data, it works properly, but when it comes to the test data, the graph or features shows a deviation. That is, in some category, if consider as per the test data, I'm expected to graph to be like this. And if because of other concepts, if my graph is showing some another size or shape, then that is called as an overfitting. The model which works well with the trained data, but not doesn't well works with the test data. Okay, so that was the first concept we learned into this chapter. Next, we studied about the types of machine learning, that is supervised learning, unsupervised, and reinforced learning. So supervised, it means that here we are having some trained data where data is labeled, and based on that we study the model or design the model, and then we come with the conclusion. Then in unsupervised, we don't have a data label. Here there is no concept of train and test data. Directly we pass the input data, and based on that it will uh, learn the model or it will design the model. And in case of reinforced learning, it learns based on the errors. It means trial and error. On this basis, it learns. So these two concepts we have seen, that is overfitting and train and test data, and as well as we have seen supervised, unsupervised, and reinforced learning. Now we will start with the Bayes theorem. So I hope this word is very popular to you, or you might have heard this word previously. So in the previous chapters also we have seen this word Bayes theorem. So in the probability, conditional probability and Bayes theorem. So these are the terms which are interrelated with each other. That is, we can say conditional probability, the implementation is by using a Bayes theorem. So let us see what it is. Any doubt in the first 2 points? I can see the strength is too low. Okay. So here, this we have seen, that is overfitting. What is when we can say that it's overfitting, when we can say it is underfitting, and generalization. Then we have seen the example of few of the existing example from the textbook. Here, the main thing is that if we give a complex model, then we will have much more accuracy. But if we give a simple model, then uh, there might be a possibility of overfitting and underfitting. Okay. So here labeled data, it means that which is having both input and output, and unlabeled data, it means that which is having only input. That is that is only feature values will be there, and that is also not in machine readable format. Okay, so supervised learning, it means that this is a task driven. That is, I am having the task that whatever training data is there, it should give me the same output. Unsupervised learning, only input data is given. That's why this is called as a data driven. And in case of reinforced learning, we are having learn from the errors. That is, whenever we are designing the model, we will check whether it works properly. If not, again we will change that. So each of this type of learning, that is, let it be supervised, unsupervised, or reinforced, it is having its own advantages and disadvantages. And based on the circumstances, we will decide which one to be chosen for the implementation, or which one to be chosen for implementing the applications as per the requirement. Okay, so now let us start with the Bayes theorem. So Bayes theorem was named after the English mathematician, that is Thomas Bayes, who worked extensively in decision theory, that is a field of mathematics that involves probabilities. So in the third chapter also we have seen in the probability, that is dependence and independence, then conditional probability, then Bayes theorems and Bayesian inference. So these are the points we learn into the probability. So now we are learning about the Bayes theorem. So this actually Bayes theorem is taken as a base for many of the models for solving. Here probability means that here we are predicting something, and that's why Bayes theorem is having much more weightage into the machine learning field. So Bayes theorem is also used widely in the machine learning, where it is simple, effective way to predict classes with precision and accuracy. So here, that is whenever we wanted to predict a class it means that I'm performing division between the given samples or given data. If consider I'm having data of 100 flowers, not belong to the single category, I'm having data of multiple flowers, then here Bayes theorem will be used for classifying those into the similar properties. Okay, then Bayesian method of calculating conditional probabilities used in machine learning applications that involve classification tasks. So here we can say that conditional probability, from that Bayesian or Bayes theorem is one of the uh, case study we can say. Okay, so it is this method is used to determine conditional probability, that is a probability of one event occurring given that another event has already occurred. Okay, for example, here we are seeing the example of, it means in the last lecture, in the last chapter, here we are seeing the example of two tests, that is two tests, that is if a student, that is there are two tests considered conducted into the class, and you wanted to check how many of the students who passed into the first test will also pass into the second test. That is, one event has already occurred. Then I wanted to check, that is based on which conditions of the first test passing, how my second test passing percentage will change. Okay, so here that is called as a conditional probability. Here we will see two examples today. So because a conditional probability includes additional conditions, that is more data, it can contribute to more accurate results. So okay, let us go for the example now. So before that, let us see what is meant by a conditional probability. So conditional probability means that, consider that there is an event A is there. Okay, so event A is there and event B is there. Okay, so the probability of occurrence of an event A when another event B in relation A has already occurred. Okay, I wanted to check how my A will occur, or a probability of occurrence of the A, where whatever B is there in relation which is having relation with A, that has occurred. Then conditional probability means that where because of B, how much A can occur. Okay, so that is given by using this formula, probability of A or B. That is A based on condition of B. I wanted to check how the A will occur based on the condition of B. So Bayes' theorem describes the probability of occurrence of an event related to any condition. If you are not clear with the Bayes' theorem in the last previous chapter, so now you can ask the questions during this. So still I'm explaining this because already we have covered, but let us see, that is again language I have changed. So it also considered for the case of conditional probability. Bayes' theorem, that is one of the cases of the conditional probability. So here, Bayes' theorem is also known as the formula probability of the causes. Causes, it means that because of B, how I'm affecting for the occurrence of the A. Okay, so in shortly that, म्हणजे समजा माझा B जर ऑकर झाला तर माझा A ऑकर होण्याचे चान्सेस किती आहेत. Okay, it means that this is acting as an origin, and from that origin, what is the probability that A will occur or A might occur? That is, this is given by a cause. Cause, it means that because of B is happening, this will initiate or will contribute A to occur. Okay, and that's why that is called as a cause. So here that is an example. So if we have to calculate the probability of taking blue ball from the second bag of the three different bags of the ball, where each bag contains three different colors. Okay, I wanted to take the blue ball, but I am having three bags. Okay, red color one bag, blue color and black color. Okay, so here we wanted to calculate probability taking blue ball from second bag out of three bags. Okay, second bag, it means that first bag out of these three, anyone can be first bag, and for the second time I wanted to take a any bag, and from that what is probability that I will have a blue ball. So in this case, the probability of occurrence of an event is calculated depending on other conditions known as the conditional probability. Okay, so this is actually a statement, that is official statement for the Bayes theorem. So let us consider E1, E2 and En be a set of events associated with sample space yes. Okay, where all the events E1, E2 up to En have non-zero probability of occurrence. They form a partition of yes. Okay, sample spaces, it means that whatever my red, blue, black balls are there. Okay, so partition, it means that Just like I'm separating these into the bags, there is no there cannot be a randomness. That is, they might mix or etc. Okay, so E1, this is my separate event. E2, this is my separate event, and En will be having a separate event. So let A be any event associated with yes. Then, according to Bayes' theorem, so Bayes' theorem says that occurrence of either of these events based on the A, okay, let it be any event. Let it be I wanted to have blue ball or black ball or etc. Okay, and be any event associated with yes. Then according to Bayes' theorem, if I wanted to check, then this is the formula based on which I can calculate whether this, what is the probability of occurrence of that event. This formula also we have seen in the previous lecture. So I will not give how this formula is calculated. So this is simply a output of series of the solves, series of cancellations and multiplication and solving of equation. And this is a final equation we can say. So here is another example. So if I wanted to calculate for this, then how we can check? Any idea? Okay, this is the formula. So here, my event E1 is, consider that I wanted to check for the red ball. Okay, E2 is regarding finding the blue ball, and E3. Okay, E3, this is regarding finding a black ball. Okay, so red, blue, and black. So these are the three bags, or I can say, uh, there are three bags, B1, B2, and B3, and out of that, these are the three events. Events, it means that I wanted to check how much this red will occur. That is, what is the probability that red will occur, or the ball is whatever I'm taking ball that is red, or whichever ball I'm picking from the bag that is blue or black. So these are the three events. Okay, three events. So what is the probability of occurrence of this? If consider I'm talking about this event, then what is the chances that I'm getting a blue ball, or what is the chances of getting a black or red ball? Any idea? As there are three bags, I can say that probability of event E1 is equal to 1 by 3. Yes. Then similarly, I can say for the E2 also, that is probability of this event is also I can say 1 by 3. Okay. And probability of 3, that is third event might occur. This is also 1 by 3. Okay, that is there are three bags. Randomly, I can go to any bag and get the ball. And each bag is having the same colors of the balls. It means that there is equal weightage for the each of the. Just like if we go for the coin flipping, then head and tail. Two possibilities, 1 by 2, 1 by 2. Right now, there are three bags. That is probability of occurrence of this event and total number of the events. So either of the three bags, I can take any bag, and probability that this might be a ball of bag of red balls, that is 1 by 3. So here, this is the events. Okay, now here A event says that, here event A says that If we have to calculate probability of taking a blue ball from the second bag out of three different bags of ball. Okay, second bag. Second bag, it means that initially I'm considering the first bag where I have taken one ball, and second bag, it means that what is the probability of second time whenever I'm taking the ball at this point, what is probability that it might be blue. Okay, so for this purpose, let us calculate as per the formula. So here A is that second event, second bag I'm buying, and here I wanted to get the blue bag. Okay, this is my event. Then, any idea? Probability of EI, that is E1, E2, E3, there are three events, and this event A might occur. So K is from 0 to N. So let us put into the formula P of E1. This I wanted to calculate. Equal to, with respect to E1, let us consider that is regarding the finding a red bag and blue. Oh, sorry. Here, second bag I wanted to calculate. So first event we might consider that. Okay, let us put the values into the formula without checking for that. So event E1. So if I'm going for the I, so I, it means that I'm talking about with respect to this event. What is the probability that in the second bag, I might find the blue ball? Right now, the first bag, I'm considering that it is going for the getting the red ball. So probability of first bag, 1 by 3 multiplied by, with respect to P, what is the probability that second time I may go for finding the blue ball? So here, what is the chance? That is second time I may get a blue ball. Is anybody in line with me? Giving any opinion why there is 1 by 3, what is this, or etc. Okay, I will answer now. If consider, I'm talking that the first time, if I'm getting the red ball, then with respect to this event, if I'm talking that event A might occur, then it means that in the second chances, if I'm skipping this event, then getting a blue ball, I'm having half probability. That is, in the second event, I will have 1 by 2 probability that it might be blue, because second bag we are talking about. The first bag is already even. Okay, even the red bag is already taken, and that's why here whenever we are talking about the remaining bags, remaining events, or second time we are having only these two probabilities. And if respect to these two, if I'm talking that there might be blue or there might be a black ball, there is half probability, and that's why here 1 by 2 will be there. So this is my denominator. Sorry, this is my numerator, and let us go for the denominator. So denominator says that I need to perform n to k minus 1. So right now this formula is actually difficult. Let me simplify this. Okay, the previous formula we will decide. Actually, this one is the formula. If consider we are using a base theorem. Okay, I think I have shared only this much. Okay, let us go for the formula only. Then summation of all the formulas, that is 1 by 3 plus. Right now, K we are considering only one. That is, we are checking with respect to the this event only, and that's why here right now K is our one only. That is, with respect to the first event only, we are checking the probability of second bag to be blue. Then 1 by 3 plus, so n doesn't consider, then multiplied by that. So A of K. So sorry, summation. I need to go for addition of all the events multiplied by occurrence of A with respect to the P. Then 1 by 2. This will be my denominator. So after simplifying, I can say, so 1 by 3 multiplied by 1 by 2, I will get 1 by 6. Then divided by this. 1 by 3 plus 1 by 3 plus 1 by 3, I will get 1. 1 multiplied by 1 by 2, I will get 1 by 2. So 1 by 2. So after simplifying this equation, I will get 2 by 6, which is equal to 1 by 2. There is probability that I may get a blue ball during the second bat, that is a 1 by 3. Okay, clear with this? So if you are having the query, you can answer into the chat window. Still, we will take two examples. So now, here, this is actually much more simplified example. We can say instead of two bags, sorry, three bags, we are having uh, two bags with two types of the colors of the balls. Okay, so bag one contains 4 white and 6 black balls, while another bag 2 contains 4 white and 3 black balls. Okay, total number of the balls here is 10 in the bag 1, and in the bag 2 we are having total 7 balls. Now one ball is drawn at random from one of the bags and it is found to be black. Then find the probability that it was drawn from the bag 1. Okay, so here we are talking about event occurrence, that is black ball is the output. Then we wanted to find out the probability that how this might happen. That is what is probability. This is from the bag 1. Okay, for this then we need to list the events, that is which are the events might occur. So E1, that is be a event of choosing bag 1, and E2, that is event of choosing the bag 2, and A be the event of drawing a black ball. Okay, there are right now we are talking about two events, that is E1 and E2. Bag 1 might be there or bag 2 might be there, and A is a separate event, that is a black ball might be there. So we are talking what is the probability of occurrence of A with respect to these two events. Okay, so having either of the ball, having either of the bag, that is half probability, as there are two bags are there. Then we wanted to calculate if we are talking about this event, then what is the probability that we might get a black ball? Okay, so as in the bag 1, there are total 6 blacks are there and 4 white are there. So it means total there are 10 balls are there. So because of which this probability will be 6 by 10 will be there. After the simplification and dividing by the 2 to each denominator and numerator, I will get 3 by 5. Okay, that is occurrence of event A with respect to the event E1 we are calculating. म्हणजे A इव्हेंटची प्रोबॅबिलिटी ज्यावेळेस इव्हेंट E1 ऑफर होतो त्यावेळेस A हॅपन होण्याची प्रोबॅबिलिटी किती आहे that we are calculating. Again, when with respect to the event E2, okay, event E2 जर calculate केला तर A ऑफर होईल याची काय प्रोबॅबिलिटी. So in that 2. We are having 4 white and 3 black balls. It means total there are 7 balls are there. Okay, 7, that is it might be black 3 by 7. Okay, so this is the event. Now we wanted to calculate, that is, if event A has already occurred, then what is the probability that even might have occurred? Okay, so for this purpose, again we calculate this formula. So by using Bayes' theorem, the probability of drawing a black ball from bag 1 out of 2 bags here, out of 2 bags, I wanted to check whether that bag is first bag or not. Okay, so even with respect to the A equal to probability of occurrence of event E1 and probability of occurrence of event A with respect to the E1. Okay, divided by probability of occurrence of event E1 with respect to the probability of occurrence of event E1 plus probability of occurrence of event E2 and probability of occurrence of A with respect to the E2. Okay, so here main question comes, why we are calculating this? कॅल्क्युलेट याच्यासाठी करतोय की इव्हेंट ए हा तर ऑलरेडी ऑफर झालाय, पण तो असा असू शकतो की इव्हन मुळे पण झालेला असू शकतो किंवा ई2 मुळेही झालेला असू शकतो. आपल्याला काय प्रोबॅबिलिटी काढायची की तो इव्हन मुळे झाला का. ओके, इट मीन्स दॅट here I wanted to check event A has already occurred. I wanted to check whether cause of this A is E1 or E2. म्हणजे इव्हेंट E1 मुळे माझा A झाला का E2 मुळे माझा A झाला. ओके, सो दिस वी वॉन्टेड टू कॅल्क्युलेट. आणि माझी प्रोबॅबिलिटी कशासाठी कॅल्क्युलेट करायची की A तर ऑलरेडी ऑफर झालेला आहे, मला काय करायचं की E1 मुळे माझा A झाला का ते मला कॅल्क्युलेट करायचं आहे. अँड फॉर दिस पर्पज वी आर अप्लाइंग दिस फॉर्म्युला. So put the values as per the requirement, and there I can say that there is a 7 by 12 probability. So you might be thinking why we are learning regarding this probability here. Now let us go for some scientific example where we can go for applying the Bayes theorem. So before that, do you want to take a look at this for a minute? Okay, so first read a problem statement for a minute. Then we will go for the first half of the answers, and second we will go for the remaining half of the answer. So please go through the question first. Okay, done. So now let us go for where we can actually apply machine learning concept, that is Bayes theorem in the machine learning. Okay, so here whenever we wanted to check, that is the event might occur or this might happen. So here it means that at the initial stages we might guess that in future this might happen, etc. So here for predictions, for prediction of the diseases, for prediction of the weather forecasting or up and down, etc. of the stock market, we are applying the Bayes theorem. So probability completely applies for the prediction purposes based on the previous events or conditional events. Okay. So Bayes theorem stated mathematically as the following formula. That is, this is the simplest formula we can say. So here B or A, it means that I'm talking about the multiple events. So here we are checking the occurrence of the event B based on the event A might have occurred, event B is occurred, but based on, sorry, what is probability that based on A, B might have occurred. Okay, so all these probabilities are non-zero values. So where A and B are events, that is P of B is not zero, then P of A and P of B are probabilities of observing A and B without regards to each other. Okay, it means that there is no connection between, that is these are irrelevant event we can say. So P of A oblique B, it means that a conditional probability is the probability of observing event A given that B is true, and reverse same, observing event B that A is true. So here, this is actual where we apply machine learning algorithms and apply Bayes theorem for calculating these values. Okay, a doctor knows that a lack of sleep causes a migraine. Okay, that is 50% of the time. That is, lack of sleep is there, then migraine might happen. So prior probability of any patient having lack of sleep is 10,000 out of 50,000. Okay, so and prior probability of a patient having migraine is 300 out of 100. Sorry, out of 1,000. Okay, so here there are two events are there. Okay, the first event says that पेशंट ज्यांना ज्यांना स्लीपची कमतरता आहे त्यांच्यामध्ये 50 जणांपैकी 10,000 आहे. ऍड ज्या लोकांना मायग्रेट होतो म्हणजे आउट ऑफ 1,000 पैकी 300 लोकांना मायग्रेट होतो. So if patient is having a sleep order, so here we are talking about this is a separate event and this is a separate event. So we wanted to calculate जर हा इव्हेंट जर ऑकर झाला तर ही इव्हेंट होण्याची किती पॉसिबिलिटी आहे. Okay, so if a patient has sleep disorder, now we are talking about this 10,000 cases out of 50,000. Let us apply Bayes theorem to calculate the probability that he or she is having a migraine. So here we are talking about the 300 cases. So probability that migraine will happen based on sleep order, because of sleep order, how much probability that migraine might happen. So again, when we talk these two as A and B, so we can say that this event is B, this event is A, then equal to event B because of A, that is, and event B because of A. Okay, so here we are dividing this. So sleep order migraine, that is 0.5 multiplied by 10,000 divided by 50,000 divided by 300 divided by 1,000. So here there is a 33% chances are there. So in the above scenario, there are 33% chance the patient with a sleep order will also have a migraine problem. Okay, so this is how actually where the application of Bayes theorem can be applied. Okay, ज्या पेशंटला स्लीप डिसऑर्डर आहे त्याला मायग्रेन होण्याची प्रोबॅबिलिटी किती आहे So that we are calculating. That is, migraine might happen. It might be happening because of other reasons. I wanted to check because of sleep disorder whether this event will occur or not. Okay, so please study this example for a minute. So anyone want me to repeat this example if you're not clear with? If not, now let us go for the next point. Okay, so before going to the next point, not only in terms of predicting the results, there are many applications of Bayes theorem are there. So let us see which are the other applications are there. So one of the many applications of Bayes theorem is Bayesian inference, that is a particular approach to statistical inference. So here, this point also we have seen. So Bayesian inference, it means that because of the existing conditions, I wanted to go for a change or height or peak values, etc. So here we have seen a bell curve, bell-shaped curve, where Bayesian inference is there, where the value reaches to its peaks, and when downfall will be there or upgrade is there, etc. So Bayesian inference, that is one of the applications where we applied the Bayes theorem. So Bayesian inference has found applications in various activities including medicine, science, philosophy, engineering, sports, and law. Okay, in many fields, Bayesian inference is used. For example, if we can use Bayes theorem to define the accuracy of medical test results by considering how likely any person is to have a disease and the test overall accuracy, then it means that we are predicting some diseases at the early stages and we can take the precautions based on that, or what might be the initial symptoms, etc. So for this purpose, we are using Bayes theorem. So Bayes theorem relies on consolidating prior probability distributions for to generate posterior probability. Okay, so it means that here prior, it means that initially at the early stage, or we can say the very early time, distributions to generate posterior probabilities. So it means later on might happen, etc. So in basic statistical inference, prior probability is the probability of an event before a new data is collected. Okay, so priority means that prior probability is that of an event where new data we are collecting. That is, before collecting the new data, if we are predicting, then that is called as a Bayesian inference. Okay, so any doubt on this? So here we have seen a Bayesian inference, the formula, and three examples we have seen. So previously this example regarding occurrence of blue ball, then occurrence of black ball, and having a patient which will be having migraine if sleep order is there. Okay, so read these applications for a minute.